Hello, so I'm Mike Bramford, and I'm here to talk to you about HTML versus PDF. A bit of background, I'm the CTO at bfo.com. We develop PDF software in Java. I've been working on the internals of PDF for about 25 long years. As well as being a member of several PDF technical working groups, I'm also a member of the CSS working group at the W3C, so I have a foot in both camps. This presentation is on the web. You can follow along if you want, photograph the enormous barcode or type it in. I'll show the link later. You don't have to decide now. So why did I choose this topic? Why HTML? Why PDF? And why compare them? Surely the answer is obvious. This is PDF days. The answer is PDF. At a different conference, I might get a different answer. And I don't think it is obvious. HTML is dynamic and transient, PDF is fixed. And whether those are strengths or weaknesses depends on what you're trying to do. But what I do think is interesting is these are the only two options. Both are platform and vendor neutral, both are roughly 30 years old. Yes, there are specialized formats, but for general interchange, these are really the only two options. But obviously HTML and PDF serve different purposes. HTML is for screen, PDF is for print, everyone knows that. Not necessarily. This came into my inbox 12 years ago. I've been waiting for an excuse to quote it. I'm very pleased to be able to do that today. HTML and CSS can do serious layout. Of course, there are other options, XSL FO or proprietary options like InDesign. But being able to generate a hardcover, paperback, or large print copy of a book just by changing a style sheet is very hard to argue with. And there are more HTML layout engines for print than for screen. 97% of page views today are made in a layout engine written by Apple or Google, whose Blink layout engine underpins browsers like Chrome, Edge, and Opera. The remaining 3.5% is Mozilla's Gecko. In print, we have multiple options, all independent, several open source, all mostly compatible, as well as print-based layout engines based on Blink and those that run in the browser as well. Now, not every PDF starts life as HTML, of course, but it is a significant proportion. So I wanted to find out how far we could push the HTML before we have to collapse the page down to a bitmap, and we really don't want to do that in PDF. And of course, once we have a PDF, it is the end result, isn't it? Not necessarily. Now, obviously, there is more HTML conversion to PDF than the other way around, but I would very much like to highlight this text from the European Accessibility Act. Now, PDF does not reflow, and that is a problem. Well, HTML does reflow. It reflows very well, and it is arguably the most battle-tested document format in history, by which I mean the HTML and CSS parsers are both deterministic. So you can take a malformed input and the output is predictable. I know of no other file format defined this way. Let's see, where are we up to? Yes, and just to hammer this home, what this actually means in practice is there is no such thing as a web page that is too damaged to load. Now, we can't say that in PDF. So, if we have to reflow a PDF, why don't we convert it to HTML? Now, I realize this is as much a political question as a technical one, but we don't have to tell the user that's what we're doing. It can be done inside the PDF viewer. Most web users are familiar with reading mode, for example, so having a reflow mode on a PDF viewer would be easy enough. And once we have HTML, well, we can display it anywhere on any screen size. And of course, if the European Accessibility Act is the concern, then the documents we're starting with are already PDF UA. All the semantic content is tagged by definition. That's most of the work done. Now, this is one of two slides where I'm giving you my opinion, not a fact. I've marked it. There we are. So, I could be wrong. But in order to find out, we need to see how practical it is to convert from PDF back to HTML. Can it be done? Let's find out. We're in Berlin. I have a quote from Otto von Bismarck. He did not say this. It wasn't him. He had no opinion on PDF either. But I'm going into the internals of both file formats, so it seemed appropriate. we need to get started, so we will start with colour. Colour on the web is RGB, specifically sRGB, a colour space designed to reproduce accurately on consumer hardware of the late 1990s. PDF, of course, has a much richer colour model, as well as device-dependent CMYK. We have calibrated colours like lab or ICC. We can have named colours, that's the device N row on the table. Now, 20 years ago, this might have been a particular Pantone shade. Now it might be white that we would underprint when printing on a coloured substrate. It could be special printer metadata like a cut or fold line. It could be a varnish layer. HTML colour, very limited. PDF colour, very capable, or at least it was. Now, a few years ago, we got a new specification. CSS got some new tricks. Lab colour, ICC colour, even device-dependent CMYK, all came to CSS. Several ICC colour spaces in particular were picked out, mostly high gamut RGB spaces. Now, it's pointless trying to talk about high gamut RGB and demonstrate it on an overhead projector, which is not known for its colour reproduction. But if you are following along on the web or on a phone, bear with me, it will make a bit more sense. So the three boxes in the right here are 100% green in three different RGB colour spaces. sRGB, Display P3, and Pro Photo. Now, if you've got suitable hardware, each one of these boxes will be brighter than the one to the left. So I have an iPhone 11. If I view this page on in my iPhone, it has a Display P3 color, Display P3 capable screen, and a contrast ratio of 1400 to 1. So the two boxes on the left, there's a clear difference. My colleague has an iPhone 15, and all three boxes are quite different. And I'm told that on reference hardware under studio conditions, the box on the right is so bright it actually hurts your eyes, which I'm quite pleased with. And that leads me to my next slide, actually. What is driving this is hardware improvements. Apple and Google and Samsung dominate the handset market. They were very quick to adopt the high gamut RGB spaces, but have shown little interest in regular ICC or device CMYK. So these have been pushed back from CSS Color 4, which is widely implemented, to CSS Color 5, which is still in draft. But that's okay, actually, that's still progress. Up until now, most of the print-focused layout engines have had slightly incompatible ways of specifying CMYK and ICC color. But any standard, even a draft standard, is pushing us all towards compatibility, and that is a very good thing. There's one more item on the slide which I need to address. OK Lab. This probably won't be familiar to most of you, even if you're working with color. It's a new color space, first published in 2020. It is designed to correct the perceptual irregularities in CIE Lab. That was published in 1976, and that's the lab color space that we all use in PDF. Both are infinite gamut lab spaces, both are lossless, so we can convert between one to the other without loss. I'll cover LCH on the next slide. And we have a small problem in PDF, the XYZ space. This allows you to specify colors directly in the CIE XYZ space. And this is actually working in all browsers today, but it's slightly awkward for us in PDF. XYZ is normally used as the profile connection space for ICC color, so it's trivial to create an ICC color space that supports it. However, we actually can't use it in PDF. ICC in PDF is limited to grayscale, RGB, lab, or device CMYK. So any time we encountered an XYZ color on the web, we would have to convert it to lab. Now, in practice, this is a hugely unintuitive color space, and I predict it will never be used. So, I have claimed that LCH and lab are basically the same on the previous slide, and here's why. They're just two ways of describing the same color. Lab uses Cartesian coordinates and LCH polar. It's the same analogy for sRGB and HWB and HSL, which are both really just polar views of the RGB color space. So here's the question. If these are all the same color space, why does CSS allow both syntaxes? And the answer is gradients. if we want to interpolate between two colours, it's not enough just to specify the end points. We also have to specify how we get from one to the other. Now, gradients have been in CSS for many years, but now we can specify the interpolation space as well. On the left, we have 3 gradients with identical colours at either end, but they interpolate in different spaces. In the top, sRGB, lab in the centre, and LCH at the bottom. And on the right, the diagram, which I hope is reproducing cleanly, is a view of the lab colour space. Now, I apparently have a laser on here. Yes, there it is. The lab interpolation line is the straight one through the middle. It passes through the centre where A and B are both 0. So the centre of this gradient is grey. The LCH interpolation follows the curved line around the outside, so the centre of the bottom one is purple. Polar spaces like LCH are actually very intuitive once you start using them, and they are really useful when you have a high gamut display, as we have on our phones or laptops. So I predict we'll be seeing a lot more LCH on the web. PDF, it only has lab, as I mentioned. But actually, this doesn't matter. PDF specifies interpolation using a function. Now, that function can be anything. In CSS, interpolation is always linear. However, we can chop it into smaller segments. This is actually one single gradient at the bottom of the screen. It's been divided into 24 different segments. So it turns out that this all works out to the same thing. And that brings us to our first conclusion. Any linear or radial gradient we can present in HTML and CSS can be converted to PDF without loss, and that is true in the opposite direction as well. That's a good result. In PDF, gradients are known as shading patterns, and as well as linear and radial, we have 5 other types, although they're really all just types of tensor mesh. SVG only has linear and radial, but CSS added conic gradients about 4 years ago. Now, these are just linear gradients wrapped around a circle. PDF doesn't have these, but it turns out we don't need them because they are also just a particular type of triangular mesh, where each triangle shares a common point in the center of the circle. So PDF can handle conic gradients too, but interpolating triangular gradient meshes can be expensive, and a lot of PDF viewers take a shortcut here, and they do this in sRGB. Now, this means that the color at the center of each triangle can be incorrect. The solution, or the workaround rather, is to do what we did with the linear gradient on the previous page. We just chop it into smaller triangles and stitch them together. So any conic gradient can be reproduced in PDF without loss. This is not necessarily true in the other direction. Well, what about that other direction? What if we have a PDF with a mesh gradient and we want to convert it to SVG? The meshes were proposed in SVG, they've never been adopted, never got beyond draft, unfortunately. But if you really want to do this without just converting it to a bitmap, you can do it. You divide the mesh into Gouraud triangles, you draw a red, green and blue linear gradient over each, and you overlay them. Yeah, it does work. As you can see here, this is a live example in SVG. However, if I'm honest, I am just showing off at this point. It is expensive, it's slow, the SVG is enormous, and really you're better off just converting it to a bitmap. Raster images are not ideal in PDF. On the web, they are fine. So, that's gradients. And we have some conclusions. First, any CSS or SVG gradient can be represented in PDF without loss. And the second is, while it's not necessarily true in the other direction, if you really want to make it work, you can. Of course, there is more to graphics than colors and gradients. Oh, that's not supposed to be rotating yet, but clearly I've messed up my slides, so bear with me. All right, I've given away my reveal. Linear and Bezier gradients are universal. Raster images too, after you decompress them. And these are all placed on the page with an affine transformation. Everybody's favorite 3x3 matrix. These concepts are universal. They apply in SVG, in PDF, and in most graphics systems as well. Of course, we now have a 3D transformation, which you saw earlier. So the problem is that in CSS, 3D transformation, affine transformations are 3-dimensional. On PDF, they're only 2-dimensional. Now, at first glance, this is a problem. But actually, it turns out to be not too bad if you're prepared to do some maths. A line under both systems remains a line. That's what the affine in affine transformation means. So for a line, it's enough to just transform the two endpoints. And it turns out that's the same for a curve as well. Linear gradients, same thing. Other gradient types would need to be converted to a triangular mesh before you convert the points, but that works as well. Text, well, glyphs are just shapes. Convert the text to shapes, draw them onto the page, and overlay with invisible text. This is the same technique we use to make scanned images searchable. Very widely supported and valid even in PDF UA. Raster images, yes, we do have to resample those. It is expensive, but this browser is doing it at 30 frames a second, and we only have to do it once. And that brings us to the final step, blending and composition, the process of combining multiple layers onto one. Now, anyone that's read the PDF specification will recognize these ducks. The good news is the blend modes are the same in CSS and SVG, so I can blend them in real time on screen. Masking, yes, this is the basically combining multiple layers. It allows us to determine how much of each layer is combined with the layer behind it. Think of the alpha channel as in an image as a simple example of this. Now in PDF we have a single masking layer. It can be drawn with any PDF operations, and the masking value, the blending value, is taken from either the luminance or the alpha of the masking layer. Well, in CSS we have multiple masking layers. The source for each must be an image, but it can be an SVG, so it's not just bitmaps here. And for each of those images, it's the alpha or luminance value. And all of these are eventually combined into a single masking layer. So what this means is when we have a web page containing this and we need to convert it to PDF, we have faced the prospect of combining alpha and luminance masks into a single layer. Now I have three bits of good news here. First, nobody does this. It was first specified in CSS 10 years ago, last week I think. Chrome only added support for this 18 months ago, so it's very rare. Secondly, if it does happen, you can do it in PDF. And the third bit of good news is, to be honest, it's so complicated I don't actually have time to go through it. I did try. I'm going to have to move on to the next topic, so you've all avoided quite a nasty section actually. As well as, but if you want to talk about that one, ask me afterwards, I should say. So PDF also has overprint. Now this is a particular type of blending mode which is designed to simulate the way ink is placed on the page by a printer. It is very PDF specific, and really if you encounter one of these and you're trying to convert back to HTML or SVG, you just convert it to a bitmap. And of course, PDF can do all of these blend modes in CMYK. CSS is RGB only. But before we get too cocky, CSS also has two new blend modes, which are not in PDF. Now I developed this presentation using Safari. When I came to try it in Chrome, I found that the plus darker example on the top right wasn't working. So it turns out that Apple had underspecified the algorithms, and most of the browsers hadn't actually implemented plus darker. So they've now changed this. If you follow the links down at the bottom, it will take you to some more detail. And I expect we will be seeing plus darker in the Chrome and Firefox very soon. Should we add plus darker and plus lighter to PDF? Well, if we want to convert web pages to PDF, then yes, I think we must. And even though we are dealing only with RGB in CSS, with blends, gradients, and frankly far too much spare time, you can do some extraordinary things. Now this is a web page. It has 78 div elements, effectively, which have been clipped, masked, merged, and gradient filled to produce art. Actually, I've cheated. This is not that. This is a screenshot of that, because displaying it even in a fast browser takes about 2 seconds, and because the PDF version of this presentation is tagged, and I didn't fancy having to tag this. So the artist is Ben Evans. He's a very clever man. He publishes the source for these artworks on his website. It is worth a look just to see how he abuses the CSS to produce these images. Debugging this in our HTML to PDF converter was hell. But that's enough. That's the halfway point. Thank you very much. We are through that, and now we're on to fonts, for which I apologize in advance. So, text, let's start at the beginning. To get text on a page, we start with characters, A, B, C, etc. These are symbols who have their semantic meaning defined in Unicode. We then go through a layout process to convert those characters to glyphs. Now, in European languages, we don't really think about this process because an A is an A, a B is a B, and so on. However, there are almost 2 billion people whose primary language involves a more complicated layout. So this Hindi text on the right is an example. We have 5 Unicode characters in red, which combine to make the 2 glyphs on the right, in very non-obvious ways to my eyes. This process is called shaping. And when you load an HTML page, the browser converts the characters to glyphs using a text shaping engine. So Microsoft has Uniscribe, Apple has Cortext, and the open source HalfBuzz library, very well respected, used on Linux, Android, and elsewhere. So in PDF, it's the same process, but this time the text shaping takes place in the PDF creation software. And it's the process, the positioned glyphs, which are written to the page. Now, for a long time, that's all you got. And actually, if you're printing or viewing on screen, it's all you need. But if you want to select text, or if you want to make the document accessible, you need a reverse transformation to convert those glyphs back into characters. In PDF, we use a CMAP for this. Commonly, the 2 Unicode CMAP, which converts glyphs to characters. Where there's ambiguity, where there sometimes is, say if a glyph has 2 meanings depending on context, we can mark it with a short section of actual text to remove that ambiguity. So broadly, characters to glyphs involve shaping, glyphs to characters uses a CMAP. I call these 2 models early layout for PDF and late layout for HTML. They're very different, but the end result is the same so long as your text is fixed. If you're trying to do this in a form field, I have some bad news. The tables that are used to do this are normally removed from the font, so the browser will, or the PDF viewer will normally replace the font. So let's look at fonts. Many years ago, we had many options. Now it is just OpenType, although there are at least 6 different types of OpenType glyphs, so this is not the progress it appears to be. It's a bit unfair, perhaps. WOF and WOF2 are very common on the web, but they are just forms of compression of OpenType. And the vast majority of OpenType fonts use either TrueType or compact font, CFF glyphs. These have both been in PDF since the very beginning. In fact, for a long time, nothing changed in OpenType, but in the last 10 years, we've had 4 new different types of glyph format, all added to the spec, all almost exclusively to do with color fonts, emoji, basically. We'll come back to them in a minute. But first, another innovation, variable fonts. Now, these are part of OpenType, but they are not supported in PDF. So, if a glyph in a font is a sequence of points with curves drawn between them, then a variable font is a way of adjusting those points. The idea is you create one master font, and you adjust the points to create a bold, oblique, or compact, perhaps, version of the font. First time I saw this, I thought it was a gimmick, but actually you can create some very high-quality fonts, and there's a whole generation of people like myself rediscovering optical sizing for different stroke widths at different font sizes. PDF, we have none of this. We only have Type 3 fonts. So when you print a page containing emoji, part of the job is converting the OpenType fonts to a Type 3. Goodness, I've jumped a whole section. In PDF support, to support variable fonts in PDF, forgive me, our job is to take a cut of that font. Basically taking the current variation of the font that we are displaying on the screen and creating a static version of that font. So in the PDF version of this presentation, the title is 14 different fonts, one single glyph in each. Now in this PDF, they work out about 8 kilobytes per font. I haven't really made any attempt to reduce that. Experimentally, we find a Latin font with maybe 50 glyphs comes out at 25 to 60 kilobytes, say. It's not excessive unless you happen to have lots and lots of fonts in your document. Alternatively, you can convert to Type 3. this is actually very space efficient if you only have 1 or 2 glyphs. So if I print this page in Chrome, I will get type 3 fonts making up the title. In Firefox and Safari, they use TrueType. So the lack of variable fonts in PDF is not a problem. We even have a naming application note telling us how to name these static fonts. Now, for most workflows, the name is not important, but when you're combining multiple documents into one, you often wind up with multiple copies of a single font. Consolidating those down to one font often starts with matching on name. Name is also critical for unembedded fonts, but I wouldn't recommend you try that with variable fonts. Racing on, colour fonts. This is the other big innovation of the last 10 years, allowing children to communicate entirely in emoji. Early versions of these were bitmaps only. We have 2 bitmap formats, one from Microsoft, one from Apple, forgive me. Microsoft then added colour fonts, colour V0, which are simple layers combined to make colour glyphs. Shortly afterwards, Adobe and Mozilla proposed SVG glyphs were added to the OpenType spec. Now, if you're aware of the font format wars of the early 90s, this process might be starting to look a little familiar. SVG is platform neutral. It's very capable. It should have been the end of the process. Google thought otherwise. Citing performance, they refused to implement SVG fonts, and as their layout engine is about 70% of the market, unfortunately, it looks like it might be the end of the road for this format. Instead, they have proposed Colour V1. This looks very similar to SVG. The font format wars are not over yet. Now, PDF doesn't support any of these. Instead, we have type 3 glyphs. So when you get a page with emoji, part of that process of converting it to PDF involves converting those OpenType fonts to type 3. Now, this is very easy to do with bitmaps, with Colour V0, and with SVG. For Colour V1, it's a bit more complex. I mentioned it's a poor man's SVG. As well as gradients and blending, the blending models we saw earlier, it also supports Porter-Duff blending. So this is an older blending model that is not natively supported in PDF. Fortunately, whenever we encounter one of these, we can simulate it in PDF by using masking layers. Now, I've verified this. I can't demonstrate it because it's the one OpenType format we don't support in our software yet. That's coming next year. I also can't do a nice animated duck image because of various issues to do with masking. So you'll have to look at the still image and take my word for it. If you're trying to implement this, my top tip, look to the TR key on the soft mask dictionary. That will allow you to invert the mask. Oh, in color, it's RGB only in OpenType. However, we can change this because CSS allows us to override the palette of the font, allowing us to change the colors of the glyphs. Now, this might sound useless, but imagine you're printing a birthday card, maybe with a cake emoji on a colored piece of card. In order to get accurate color reproduction, you might want to underprint the emoji in white. So actually changing the colors is not quite as dumb as it sounds. It's not easy, though. Color fonts use an array of 256 colors. You change them by index. These smiley faces here using the green color spaces from before. It does work on my phone, but I'm changing color number 43, a number I came to on my 43rd guess. It is possible, it is not practical. So we made it. That is an awful lot of ground covered, thank you, and we have 2 major conclusions. First, every glyph on the web, by which I mean every glyph in the OpenType format, can be displayed in PDF without rasterizing. That is a very important conclusion. PDF is at its best as a vector format, forgive me, and now it can be vectors all the way down. And secondly, in order for PDF creation software to do the same as HTML and put glyphs on the page, we have to work very hard. We have to run the shaping algorithm, we have to collapse variable fonts to static, and we have to convert color fonts to type 3. It's a great deal of work. So that's graphics and text. I'm done with the rendering model. How long have I got? 0 minutes.
So technically we are over time, but because it's a break, I'm happy that... How many more minutes you got?
Oh, I don't know, 5? What do you reckon about that?
If everyone's happy to keep going, then
yep.
Please keep going. Otherwise, if anyone needs to leave, please do it now just while we take a short
And I won't
break.
take it personally.
Yeah, okay. Let's keep going. Thanks, Mike.
Okay, thank you for your tolerance here, getting my timings wrong. So we'll move on quickly. Accessibility, what a big topic. Lots of talk about that today. I'm not going to talk about the whole topic. I'm just going to talk about structure. Accessible docs have to be structured, by which I mean a heading is a heading, a table is marked as a table, and so on. A page is more than just a collection of words. Now, HTML has an advantage here because it's inherently structured. HTML is tags. It uses tags for layout, but actually this can be a problem. If you view the source of any modern website, you will see a paragraph is normally nested inside a huge stack of elements. Maybe 10 because your framework demands it, another 10 because you've foolishly chosen Bootstrap as your layout technique. Only 5 or so might have any semantic meaning. Well, in PDF, tags are not required and are often left out. This is a problem. It's a shame. And at its worst, it leads to what I call glyph salad, where the page is covered in glyphs with no real semantic meaning in a random order. However, this is much less common than it used to be. I think a growing awareness and legislative requirements for accessibility mean that we are seeing more tagged documents. Not nearly enough, of course. Think of the last few PDFs you created. How many were tagged? For most of us, it's not the default workflow. However, if a PDF is tagged, then it has an advantage over HTML. Because elements are not required for layout, we need less of them. So our tag trees can be flatter and simpler and much closer to the author's intent. PDF has another advantage, of course, it never changes. HTML DOM is changing all the time, normally with new adverts loading in. We don't have that problem in PDF. And there's another problem with HTML accessibility, which I will illustrate with more ducks. These ducks look the same. Of course, they are the same. The top one is put on the page using an image tag. The bottom one is put on the page using a CSS background image. Now, WCAG tells us that these are different. The top duck is a semantic duck, and the bottom duck is a decorative duck. Now, I think this is avoiding the problem myself. There are many, many reasons to use CSS to manage your images. It is convenient. It is very common. WCAG tells us that if the bottom duck really is semantic, well, the document isn't accessible, and that's true, but it's subjective. In the language of WCAG and PDF UA, this is a human check. Well, in PDF, we have to make a choice. However the duck gets on the page, we have to mark it as semantic or decorative. There's no default, and automatic checks will fail if we don't do this. This doesn't just apply to ducks, I should say. It applies to any graphics or text on the page, background colors, borders, and so on, and that's a good thing. So when a tool is tasked with turning HTML into PDF, it has a choice. It can follow the WCAG guidelines, and it can make all CSS images decorative, and that's absolutely fine as a default, but it doesn't have to be done that way. For example, in our software, we add a CSS tag allowing the author to say the background of this image is semantic too. That puts the tagging decision back in the hands of the author where it belongs. Metadata, a feature of both document objects. Now, all metadata is conceptually just a triple. If I say the document title is PDF, then the document is the subject, title is the predicate, and HTML to PDF is the object. A collection of triples is known as a graph, and HTML has many ways to embed a graph of metadata within it, RDFA, microdata, JSON, LD. HTML is extremely flexible here. If I have a web page, say, about a recipe, I could have metadata about the web page and about the recipe. That's two different subjects. And the metadata graphs I use to represent that can interact, or they can be entirely separate. Well, PDF has multiple metadata graphs too, but the subject for each must be the PDF structure object the metadata is attached to. Now, normally that's the PDF itself, but it could also be a page or a bitmap image within a page. However, PDF has no way to create a metadata structure for an abstract concept like a recipe, and there is no way for one PDF metadata graph to refer to another. PDF, basically this limits the complexity of the metadata we can store within PDF, and anyone converting HTML to PDF may have to drop metadata if it doesn't relate directly to the document. Does this matter? Perhaps not, if I'm honest. The most common use of metadata in HTML is search engine optimization, a process now almost entirely replaced by AI indexing. There's very little incentive now to add complex metadata graphs to HTML. The other problem with it, of course, is the error rate. RDFA is particularly bad here. So bad, in fact, that when the schema.org team were picking a metadata format, they settled on microdata due to the error rate. Now, 4 years after that decision, in 2015, a white paper was published that showed an error rate of roughly 25% in microdata, and that was presumably an improvement. So PDF also has this problem in metadata. We have it, ours is based on RDF XML. It is very difficult to formally validate because there are multiple ways of storing the same metadata triple in the RDF. I believe there's a talk on this tomorrow, actually. And the XMP specification itself is also not designed for formal validation. It was written slightly loosely at first, and properties have been added and removed, and their types changed over time. This high error rate is because people don't consume metadata directly. If I misformat the document creation date in this presentation, who's going to notice? What does it break, right? We might be boiling the oceans with our use of AI to create document summaries, but in this case, it's probably no less accurate than what it was replacing. Now, that's my last opinion. I figured I should probably put that one up there. I should say I'm not down on metadata in general, just I think that it's not very well supported when we convert from HTML to PDF. There we are. So forms, I'm almost done. I have very high hopes for the Forms Next project, I should say. Maybe much of what I say will be outdated in a couple of years. So in HTML, we have a richer range of form fields than we do in PDF. But the vast majority are text or buttons. Over 40% of page loads include at least one text field. Over 20% include a submit button, 14% a checkbox, with the others much less common. Both HTML and PDF buttons have predefined states, so think of a radio button can be checked or unchecked. These are static fields, and we contrast them with dynamic fields like text, where the value can be literally whatever the user types in. And it's these dynamic fields that are the problem. HTML can style them like any other element. You can set the font, the line spacing, the padding, within reason, but they are infinitely stylable. Whereas in PDF, we're almost entirely dependent on the viewer application. Yes, we can set the initial appearance, but once the user starts typing and changing the value, we are almost entirely dependent on the viewer to do a good job. We have control over our horizontal alignment. It can be left, center, or right. We can specify the font, but as we've seen, the early layout means the font may be replaced. We have no control over line space, and we have no control over the initial position of the first line. I feel that adding these two properties to the PDF spec would greatly enhance the PDF forms. Fortunately, buttons are much better in both HTML and PDF. They can be stylable in both. And many web pages restyle check buttons and radio boxes too, with some CSS hacks. Well, in PDF, we can restyle radio buttons and check boxes too. This video was taken in Acrobat. The appearance streams are preset by the author, so they can be literally anything. But although this is really common on the web, I've never seen a PDF do this. I should say the video works in most PDF viewers as well. The form fields work in most PDF viewers as well. Of course, PDF has digital signatures. HTML does not. If text fields are PDF's weakest feature, then signatures are certainly the strongest in the PDF version of this presentation. This is a real signature. You can click it to verify the integrity of the presentation. Why? Because we can. I still find something magic about being able to verify the author of a document using maths. So, PDF, of course, has other features which are unique: embedded files, bookmarks, measurement dictionaries, but then HTML has the mutable DOM. Both have individual strengths, but they have more in common, I think, than most people appreciate. There's, of course, one big unaddressed question, which I haven't tackled, the question that matters. Yes, they can both play Doom. Doom, funnily enough, the HTML and PDF spec were both published in '93. Doom dates from 1991, so it's actually older. Right, that's me. Thank you for the latitude, Peter. I wanted to say that last thing, where I've tried to describe an HTML or CSS feature, I've tried to demonstrate it live in the document. There were only 2 occasions where I had to use a bitmap to do that. We then converted the HTML and CSS to PDF using our publisher software. We actually converted to PDF A4 and UA2 just to see if we could. And the good news is that there was only one aspect of this HTML presentation that I couldn't represent in PDF A4. It was not the video, it was not the 3D text, it was the new blend modes. Both A4 and UA2 have done a really good job here. All of them versions of this presentation are available at the link HTML PDF2, and there's also a compatibility PDF1 version. Thank you for your latitude. I will take questions. Thank you.